I'm come from Vilnius. My name is Osvaldas Grigas, and it's the first time here in Tel Aviv, in Israel actually. Thanks. I don't know anyone, but I'm trying to make new friends, so you can come to me and say hello. I'll appreciate that. I want to tell you a little bit about functional programming. My talk today is a little bit theoretical on the philosophical side. If you like practical, down-to-earth stuff, you will hate it. The next guy, Nir, is going to be more practical than me. He will talk about like real-world Clojure application. I'm more towards the side of functional ideas in general, and I will illustrate it in Clojure, which is not necessary to use as a language to illustrate those ideas, but yet it's very good because it's not hybrid, it's purely functional. And if you're moving from OO to functional design, especially design, right, how to think in functions, you may find it interesting. So there's a phenomenon I call object-oriented hangover, which happens when you have done OOP for so long that you just can't think in terms of verbs anymore. You only can think in terms of nouns, especially if you live in like Java, even Scala to some extent. And so I want to introduce you to the ideas, even if you know them, like the functional design ideas. If you're used to thinking in terms of objects and designing in terms of nouns, things that are, as opposed to things that do, I will try to move you like over the barrier to the other side and show you how you can apply the same kind of design principles, but only with functions. Right? I think that there's little coverage in the middle ground between the basics of functional programming and the advanced topics. And sure, people have told me that, you know, monads are not advanced, they're really simple, and lambda calculus is really trivial, these are not advanced things. All I'm saying is these things are more like theoretical, which you don't have to know when you're starting. And the basics like first class functions and immutability, these I take as given. Like, I'm not going to talk about what it is. I assume you know what immutable data structures are. I'm going to concentrate on the part in the middle. Okay? When you learn the basics, when you do later, how do you design stuff? How do you apply what you know in OO world, your design principles, your patterns? How do you apply them to functional style? I will not talk about type systems at all. This is not about Haskell or Scala. Or hybrid languages. Scala is not a good language to illustrate these ideas because Scala is also imperative and OO, and it's too easy to segue from functional to object-oriented style when you have that ability. So Clojure does not allow you to do that, mostly. Yeah, mostly. So, design. Let me concentrate on just the design concept as a thing for a few minutes, if you will. We all know what monolithic design is. It's when you mold a brick of plastic in such a way that you can't separate it easily. So you can't think about individual colors without involving in some way all the other colors around it. And we all strive for functional, or better word is modular design, right? Where each individual part is small enough that you can combine them to produce different results. So they are designed to be small and composable, extremely composable. The nice thing about Lego is that these parts don't know anything about each other. Each one does one little thing, but it can be applied to many, many different occasions or situations to achieve different results. So that's what modular design yields, if you can achieve it. And the process of design is simply taking this molten brick of plastic and turning it into small individual pieces. So breaking things apart, that's all that design is. It's taking something complex and breaking it. And children are naturally good at designing in this regard. When you do OO design, it can be of two mindsets, I would say. So you can start from nouns and move to verbs. That's usually what most people do. It's more like static design. So you draw static class diagrams or module diagrams and say, okay, what's my system about? It has accounts, it has customers, it has maybe money, and then you connect the dots. Or you say, okay, what does a customer do? What does an account do? What are the functions? So when you start from verbs, it's the other way around. You say, okay, what are the core functions or core features of my application or system? It's things like transferring funds. And so you start from transfer. It's things like onboarding. Okay, so these are verbs that sound like nouns, but actually they're verbs. And so you start with transfer as a function, and then you try to find the nouns which naturally come attached to this function. Okay, so you say, okay, transfer between what? Accounts. Okay, what do these accounts belong to? How do they get attached to these new nouns? You start always from verbs. And it seems like a trivial exercise, but actually if you just do that, you will usually arrive at something better than this, which is not good design. And I'm not saying that all OO design is like that. I'm just saying that's most what I see in like enterprise shops. And how do people arrive at this? Well, I think partly because they start too early from nouns. They say, okay, how do I split my responsibilities? I'm going to have a data access object responsible for persistence. I'm going to have a controller responsible for rendering, and a service responsible for essentially everything else. Now, if you start from verbs, you might arrive at something different. So you say, okay, what I want to do in my system? I want to like onboard a customer. So then you will have a package or a microservice, if you will, for onboarding. How about promoting a customer? How about rendering a profile page? You might have a profile package or microservice. So I really want to push this idea that just concentrating on verbs first will usually naturally yield a better, more modular design. Because in an onboarding package, every class will be naturally cohesive with each other. Right? They will tend to change together simply because they perform one cohesive feature. And the feature is naturally expressed in verbs and not so much nouns. You might say, okay, domain-driven design is all about nouns. You have factories, you have entities, you have services, repositories. Has anyone read the DDD, the blue book?
Part of it. The table of content of it.
Yeah, okay. So okay, for the recording, it's 2 people who have read it. It's a great book. It's a hard read. Don't be scared. I still advise you to read it. It's a very good book. And it's deceptive. It seems like it's concentrating on nouns, but actually it's all about the actions, the verbs, the functions. So in this particular user story, as a teller, I want to transfer funds between accounts. What's the keyword? What's the word that everything revolves around? Transfer, right. It's the verb. Sure, you have accounts, you have funds, you have a customer or teller, but they all become attached to the central gravity point, which is the transfer itself. So always try to start with a function. And if you're coming from OO background, you will have heard of things like single responsibility. All objects should follow it, right? And you probably will guess that this particular service does not follow single responsibility principle. Now, how do I know? Yeah, that's a dead giveaway, right? When there's an and in the function name, it's probably not following the SRT principle. Okay, so what do? You split it, of course, into 2 parts. You do the design, and what do you get? You get download and extract 2 functions. The more interesting question is what objects they belong to, what classes they belong to. Any ideas?
Manager. I'm kidding.
Yeah. Well, download manager, why not? Yeah, what else? Okay, so that's my design. Okay, I have download file downloader, which has a download function, and the extractor, which has extract function. And that's what you often see when you see OO code. You have a lot of doer classes. So classes which masquerade themselves as nouns, although actually they're verbs. What would we lose if we were to just strip away classes altogether? Just get rid of classes. Just leave the functions. What? No, I'm not going there yet. I just want to get rid of classes, you know, just the functions about this size. Did I lose any information? Did these functions stopped revealing their intent by not belonging to classes? No, it's exactly the same as before. It's just less boilerplate. So you saw some Clojure. I suspect most of you have seen Clojure before. Anyone who doesn't know Clojure syntax? Okay, a few people. So for those of you, here's a normal function invocation in a normal language, like any normal language. Now what you do in Clojure is take this opening parenthesis and you move it to the other side, like this. You see what I did there? Wow. So that's Clojure. Also, you can leave out the commas, because commas are optional, they're white space. So this is more idiomatic. It's still Clojure. And now you know 80% of Clojure syntax, so we can move on. Function definition is like this. It's a defn, function name, arguments in the body, and everything is like prefix notation. So you get used to it quickly and then move on. I really don't know what the big deal about Lisp syntax is, honestly. Like that's all there is. No, just put the parentheses on the other side. And I could talk for hours for how much it yields, like how it implements homoiconicity, and you can have macros and wonderful, wonderful things by just moving this parenthesis to the left. It's pretty cool. I don't have time for this, sadly. Okay. Another example, we have product catalog with two functions, save and find by ID. Right? It's cohesive, you could say. It works with products. It's not a service. That's nice. Yet, if you try to follow the interface segregation principle, which says a client of a class should only be exposed to as much surface area of the class as it needs. So it's likely that, for example, the page which is responsible for saving, or the controller which is responsible for saving customers or products, only needs the first function. Right? If you have a page for viewing products, you only need the second function. So we have applied the rule this, we are good citizens, right? We're moving on, and we split it into a product saver and product finder, and that's just weird, right? I don't know, if you are not a little bit shaken by this design, then I don't know what's wrong with you. Something is not right. I mean, you can technically fit it, right? It technically fits, but something doesn't feel right. Of course, you have read the DDD book, and you are now smart, and you look for better names, and you say, okay, save is product repository, and find is product query. Fine. Like, how often do we play this game? Just looking for better words for nouns, because we can't have pure functions, like free functions. Yeah. If we just do that, save product and find product by ID, there's not much information we lose, as in the previous example, right? So my point here is, if you apply OOP rules like SRP principle, interface segregation, dependency inversion, rigorously to the end, you will arrive at a more functional design naturally. That's not always the case. So some principles in OO do not lead to functional design. Things like tell, don't ask. They lead more towards actor model, I would say. But these do. And so is anything missing? Can we just remove classes altogether and live happily ever after? So is there anything missing which I didn't mention in the classes?
Namespace.
Namespaces, right. What else? State, cool, state management. Anything else?
Data structures?
Encapsulation, right? Could be, okay. Yeah, nice. Actually, a lot of things are missing. We lose all of this. We lose ability to organize code through namespacing. We lose inheritance. We can't do inheritance in functions. We lose encapsulation. How do we compose things? Well, for some of you it may be clear, for some of you not. how do we do polymorphism, and eventually how do we manage state. I'll try to go through these one by one. So for namespacing, you just do namespaces, okay? In Clojure and in all other functional languages, there are primitives for what we call other modules or namespaces, which are actually packages in Java. Okay, so you just say, okay, save and find by ID belong to product repository namespace. That's it. So you can do that. It's not bound to classes in any way. And then you require namespaces and use them just as you would use an object or a class. How about inheritance? How do you do inheritance in functions? Any ideas?
You call the function and return the
It's not really inheritance, though. So multi-methods is for polymorphism, yeah. For just expressing the inheritance, I mean implementation inheritance. I want to inherit implementation of other functions in my class or function. So there's no way, you just don't do it. There are ways to express inheritance relationships in Clojure. So if I have a true inheritance relationship, like a cat is an animal and a dog is an animal, okay? So we can express just that. Just say a cat is an animal, dog is an animal, and then use that as information, as data. But there's no way to implementation inherit, as in Java, as in Scala. You just don't do that. And again, I could talk for a long time why extends in Java is evil, and you shouldn't do it. Just trust me, don't do it. If you want to do it, find a way to do it in the composition. You can always replace inheritance with composition. Okay, how about encapsulation? That's a big one. How do you do encapsulation in a language that does not have classes? So how do you, yeah?
Clojures.
Clojures, that's one way to do it, yeah, cool. But actually, let's think outside the box. Why do we need encapsulation? Why do we need to couple functions and data together? Data itself is not an object. When I say data, I mean like $100, okay? I give you $100. What can it do for you? I don't know. What can you say about it? It represents itself. It doesn't have a role. It doesn't have a set of responsibilities. It's just $100. You can say what it contains. It contains amount 100 and currency dollars, but that's about it. It may have like a serial number maybe. That's it. So data represents itself. It doesn't do anything by itself. So it's not really an object. I mean pure raw data. Also data is immutable. And when you combine these two, do you really need to ensure any kind of invariance? Like in a way which requires you to manage state, other than just having pure functions. There is one problem, and that's namely consistent transitions between states. If you have a multi-threaded environment, you do want to ensure that your state is not corrupted, and I'll go to that later in the talk. But for just, representing state and moving from one state to the other, all you need is functions. And Clojure really does emphasize the point that leave data alone. So Clojure really likes to give you raw data structures and just run with it. For example, HTML, the function called HTML, is essentially the main and only function you need to use in a hiccup library in Clojure. And all it does, it takes a data structure and returns an HTML string of HTML, essentially, right? So it has a very, very small surface area, this library, and it does a lot of things because it operates in raw, unadulterated data structures. And this happens to be a list of keywords which contain embedded lists, which contain a for comprehension with more lists and vectors and so on. So all of it is just pure data. Another example is Ring, which is a web server library. A request handler, just a function. It returns a response as a pure data structure, which has keys. It's a map, right? It's a map. Status is an integer. Headers is a map of strings. Body is a string, which itself can be generated from a map of JSON. So it's data all the way through. And Clojure really tries to enforce this idea of just let data live. what's the problem with objects when they encapsulate data? Each object is like its own little world, right? It says, okay, this is my data, and these are the functions I allow you to do with this data. And in this way, I'm not compatible with anything else, with any other class. So objects are not that reusable because of that. And functions, especially in a dynamic language like Clojure, are much more usable. You have very few data structures and very large number of functions. So this is actually Clojure core functions, literally hundreds of functions. And they work with pure data structures, very few vectors, lists, maps, sets. That's about it. And you can accomplish a lot by just composing them together. Again, small pieces which, when composed, achieve great things. Now, we have split things apart. We did the design, and now we want to compose things back together. So composition is putting things back together to achieve interesting results. How do you compose things in OO? You do dependency injection, so-called, which follows dependency inversion principle. And it's very good for testing and decoupling and blah, 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 blah. Okay? A small example, very quickly. I have profile page, which can render customer by ID, but profile itself does not know how to fetch the customer from the database, so it needs a repository. So it says repository, please find me customer's profile by ID, and then please, I will render it to HTML. Okay. So, and when you render, you pass the repository as a parameter to the function. So that's dependency inversion. You don't have to do it at constructor time. You only want to do it in constructor time if you want to inject it. And I'll skip through this. Essentially, well, in a functional language, or just functional programming style in general, every function is like a strategy. I like to think of it like this. Every function implements the interface which says, I am an interface which has this one function, and you can pass me everywhere where you expect a certain contract. In this case, it's a contract which says I'm accepting a customer ID and I'm returning a customer data structure. Then, naturally, you want to do composition in a dependency injection style, right? You want to say, I don't want to pass repository everywhere where I call this profile page. I want to pass in the constructor and then kind of close over it and forget about it, like this. So in a functional world, you would do a partial application. If you don't have a partial keyword, that's what it looks like. A partial application is just taking a constructor concept and moving it to a functional style. So it's just closing over the first argument, arg1 in this case, and then calling a function with the second argument as it comes along. And it's such a common pattern because it has its own syntax, essentially, in all languages. Partial, which is the macro. And I very like this quote by G.B. Rainsberger. He says that each object is a collection of partial applied functions. So if you take this concept back to OO world, you start seeing objects as partially applying all the argument lists of each instance method. So each instance method has an invisible argument, which is actually the construct argument at the front. And you can move on. I won't stick to this. You can implement adapter and decorator by just doing functional composition. So in a very simple example, I can say an adapter pattern is just composing functions together, okay? So you say comp to view model and load from SQL means I'm composing two functions and getting a third function, which just pipes the input from one to the other, like a Unix pipe. And it's essentially the adaptive pattern, it's all there is, because the pieces are so simple. Decorator as well. Okay, let's move on to polymorphism. I don't want to stick too long with this. What is polymorphism? Imagine this girl went to the other room and there's a wardrobe with all sorts of clothes and other equipment. And every time you call her, she comes to you, she responds to the call, but she looks completely different. So once she looks like this, and then she looks like a princess, and then she looks like Malvina, and the point is she's polymorphic because she responds to the same call, but you never know what you're going to get back. Just the name is the same. So that's a really weird metaphor for polymorphism. Now, why I'm doing this is because that's the idea which can be applied to functional as well. You don't have to have objects. In classes, you only have subtype polymorphism, right? Which means you dispatch on the subtype of the first argument of the function, which is this. It's always this. But you can do so much better. I can skip this, it's just too much code. I won't bother you with this. Yeah, so functional, well, not functional, OO polymorphism might look something like this. I may want to turn an object to JSON at the bottom. And this object may contain other objects. It's a composite pattern. Each of them also has a to JSON implementation. And when you say at the bottom to JSON, you get a JSON representation all the way up. Of course, you can't just say that a string is a JSON object. Okay, you have to wrap a string, you have to wrap a list, you have to wrap everything. So these are the limitations. If you feel a little bit constrained by them, you should try protocols. Now, in Clojure, protocols are like polymorphism, but like Rich Hickey calls it, a la carte. So when you need polymorphism, you can just use this as a separate thing without inheritance, without namespacing, without anything. Just polymorphism as a concept in its pure form. So you would say def protocol, JSON, which is a polymorphic protocol. It only has one function to JSON. That's all it has. Okay? And then you can make any type extend this protocol or implement this protocol. You can say a string is a JSON, and this means that when I turn this into JSON, it's surrounded by double quotes. You can then say a list is a JSON, and what this means is I join all of the mapped to JSON versions of the list by comma, and then wrap it around by brackets, and so on. You can extend nil, even you can extend anything. And then you get magic like this. You say, okay, please turn this data structure to JSON, and it just happens. And it's possible because Clojure protocols are an open type system. Okay, so these are not closed types. You can extend built-in types with your own protocols. And it's quite powerful. And you can also do multi-dispatch in multi-methods. You can dispatch on anything. Small example, I have a multi-method called greet, which dispatches on the country of the first argument. Now, what's the country of the first argument? If argument is like a structure of a person which has name and country, you can dispatch based on the country, which means if I put it like greet something which has country France, it will say bonjour Jacques. It's a contrived example, admittedly. Still, it illustrates the idea that you don't have to dispatch on the subtype of the first argument. You can dispatch on any function of any argument. So you get polymorphism a la carte. And finally, how do you manage state in functional world? That's how you do it. Everywhere you have state, imagine it as a state machine. It actually will yield better design. So enumerate all the states, like state 1, state 2, state 3, state 4. Draw the lines how you can transition from one state to the other. And what do you think those lines are? They are just pure functions, right? They take data. All of this data is immutable. You just move from one value to the other. And functions are pure functions. They just take data and produce another data, the next state. And you can model entities like that. You can model business processes. You can model state machines. All you need is actually one synchronization primitive which says, I want to ensure the consistent transitioning from one state to the other if it's a multi-threaded environment. So we need an atom. Clojure has atoms for that, which actually in Java, if you know, is an atomic reference. So Clojure atoms are just atomic references under the hood. And once you do that, you can start imagining what a class is. Class actually is just a namespace from keywords or from strings two functions, and those functions, all they do, they update the state of the class. So you can model each class as a state machine, where the state is the state of the class. It's a long and contrived example. I think I won't going to go through all of it, but essentially that's an illustration of how you can implement atomic transitioning of a class, which becomes naturally thread safe. And you can model any kind of class-like behavior like this. Now, see what happens when I do that. I automatically complex several ideas. So in order to have like a proper OO class, I will answer later, okay? I have to complex namespacing with state management, with pure functions, and probably a few other things. So what happens is this. It's an eierlegende Wollmilchsau. Yeah. Which, if you know German, means egg-laying wool milk pig. It's like an all-purpose animal, right? It's from German folklore. It's actually from German folklore. And in a class world, I would say, what's a class? It's an eierlegende Wollmilchsau. It's an object. It has everything. It has a namespace, it has inheritance, it has polymorphic dispatch, and it has data, and it manages state, it does everything. You can't pick and choose. You can't say, I only need namespacing. No, you get everything. You can't choose a la carte. So even if you keep working in OO style, in OO language, my takeaway from this talk for you, I hope you will take it away, that you can, by discipline, just treat each class as one of these things, not all of them, okay? If you need namespacing, just do namespacing. Don't do namespacing and state management in the same thing, in the same class. If you need polymorphic dispatch, just use an interface. Don't extend inheritance, okay? If you need data, just treat class as data object, as data structure, without any methods on it, any kind of, again, polymorphism, anything like that. Just pure data. If you do that, it's a good exercise. I promise you, your design will be better, because simply each class will be concentrated on one specific aspect which you're trying to implement. If you're interested in Clojure itself, Rich Hickey has a much better talk than I. It's called Clojure Made Simple. It's for Java or JVM developers. You can Google it. And any questions can be addressed to me now or during the beer time. Okay, so the question is, have I seen a project in Clojure that's actually models state transitions like that as a state machine? Well, one example is Datomic. Datomic is a database, and it actually does model state transitions with atoms. It doesn't even use software transactional memory. Well, it treats the database as a value, and the way you do transactions on it is just apply a function to get the next value. It's like the epochal time model.
Yeah, I get it, but I mean, you mentioned explicitly state machines. Like transducers are basically the function example of state machines, right?
Yes, transducers and streams are better at doing that.
I mean, it's the same, just the function way. So
yeah.
I was just confused. I'm like, maybe I don't know something.
No, that's right. So this talk is really entry-level talk. I wasn't going to mention transducers or other things. I just wanted to use Clojure to illustrate like the basic ideas, how you apply OO thinking to functions. So I tried to use Clojure as an illustration point, not no. Any other questions? Okay, can we wrap it up then? Thank you for listening. I'll be around.